Thank you everyone for joining us for the community session. We are really excited to showcase what we have been doing over the past, let's say, preparing for over the past 6 months. And next slide. Okay. So this is the session expectation. Before I can continue, my name is Rose Delilah Gesicho. I am the chair of the community session, or just the DLI community chair. And I'll be walking you through the session expectations. So as we get started, we have been showing you an amazing video, which is a slideshow of the legendary communities that we have. So the legendary communities I'm talking about, communities that have been affiliated with Indaba for over, the years that Indaba has been in existence since 2017. And we have the likes of Masakane, DSN, AI Saturdays Nigeria, Zindi, and the video was cut short, so we are going to share it on Slack so that you see all the legendary communities. We also have our community committee introduction and evaluation. So we did a competition within our different communities across the DLI affiliated communities, and we were able to select top 5 finalists, and then we are going to have the top 3 announced on Friday for the award ceremony. So we'll take you through a brief on how we went about the evaluation. And then we'll get a quick view of what the projects were about, the top 5. And then we get you to the panel discussion, which we are talking about funding. How do these AI communities get funding to sustain themselves? So we'll talk you through that. Yeah, so the goal for our community competition, it was mainly because we saw a challenge within our communities. We do not collaborate. We work in silos. So our goal was to tap into the community and see what we already have, projects that are already existing, projects we can build on, and showcase the top 5 because of time, and also those that are already existing, and see how we can be able to sustain and support them as we continue. So I wanted to acknowledge the team who has been behind this. This is Stephen Fashoto, Deborah, author. Again, the flags, we're representing the countries in Nigeria, Ghana. My co-chair, Alice Naomi Wamba, Philomena and Volvian are the team behind the hard work that we have put in. And of course, our communities that came to show up and show out their amazing projects. So just a breakdown of what we were able to do. We were able to gather 130 teams or 130 different communities to take part in this challenge. And we had representation in over 20 plus countries. The challenge was mainly give us something that you have been working on, be it in climate, be it in healthcare, be it in agriculture. We want to see the amazing work you're doing with African data. And the top contributing communities include the DLI Botswana, AfriClimate, DSN, and also other communities took part, but these were the most contributions we got. So I will have Volvian come in and just share briefly on how we went about the evaluation process of the competition, so that you see how we were able to select the top 5.
Hello, everyone. I'm Volvian, and it's a pleasure to be here today. So basically, for our community phase and evaluation process, we went through about 4 phases. The first phase was the registration, when we have about 130 communities that signed up. Then we went through the second phase, that was the midterm evaluation. And during this phase, 48 projects were reviewed under some very clear review evaluation criteria. Then we finally moved on to the third phase, that was the final evaluation. Throughout, we had 42 projects reviewed by experts and judges. So during these phases, we have the community that submitted their project in 2 ways. The report, and then later on the presentation. So for the evaluation process, we first of all have their project report reviewed by expert judges that we are very grateful to. And later on, the groups has to go through the presentation, the oral presentation online, still with the expert judges. And each project has at least 2 judges for transparency and fairness. So at the end of the process, we were able to select the top 5 that are going to go through the showcase today, and the top 3 will be announced on Friday during the award ceremony.
Okay, so I'll just finalize on the top focus areas. We mostly had results from healthcare, agriculture, as mentioned, climate, and language. And we had a diverse type of ideas, like just different focus areas, but these are the ones that stood out. Because of time, we'll just get into the top finalists. We have the GIL code. So yeah, please prepare your questions. We're giving them at least 8 minutes to present. If you have a question, you can raise your hand, and then we can hand it over to you. Thank you.
Okay. Good afternoon. I'm Kevin Obote, a current master's student of data science and analytics in Strathmore University. So today I'm taking you through our project, which was done by 3 wonderful team members across Africa. We had one, Madam Mary Stella Iziani, in absentia. I want to recognize her. 2, we had Madam Aika Shauri from Tanzania. And finally, Kevin Obote. So the major challenges that we focused on this challenge was 1, on language. And we've identified that language is one of the major key aspects that is attributed to growth. From the Industrial Revolution to, from agrarian revolution to industrial revolution, and now we are facing AI revolution, we need to factor in inclusivity. And it's that reason that led us to first focus on unifying language, and in this case, we utilized Swahili language, one of the languages that is spoken and recognized in African Union, and spoken by close to 200 million people across Africa and the world. The major problem that we faced was 1, the low availability of tools available in Swahili, including educational content. All the content in educational contents are either in English, and which is something that has limited many people to have access to. And in education, we had to utilize the open source resources, and in our case, we use Mozilla Corpus Common Voice 11 for Swahili, which was around 145 GB. So we utilize local resource, local compute. It was very challenging, but at the end of the day, we were able to crack it with the help of open source community and resources. So on the solution started with speech to text, where we were able to capture Swahili audio, and later on we were able to transcribe it using 2 specific models. 1, we started with Whisper, and later on we saw that Whisper was not performing well, so we proceeded to Web2Vec 2, which outperformed Whisper. Another aspect of the solution is summarization, because we have identified our key area of focus for this specific challenge is 1, to start with education, and then later on proceed to the other sectors. So summarization is one of the solutions that we are going to provide from our solution. The next one would be sentiment analysis, where even the admins who are going to use our platform will be able to have thematic analysis and understand the sentiments of what students or maybe people who are going to interact with our platform are. In addition to enable our platform to have interactivity, we have incorporated offline chats, offline and limited to low bandwidth solution that will allow you to interact with our platform easily using Swahili. And later on, the insert dashboards will be used as a report where now you can understand what you've been interacting with. So on the modeling, we started with Whisper, which didn't perform well, and proceeded to Web2Vec. In the summarization, we used MT5, MBAT, and later on for the sentiment analysis, we used DistilBAT. And only to mention, 90% of our data was identified as negative sentiments, and I believe this is something that we need to further investigate and understand why. And I believe this is related to the specific tool, because initially DistilBAT was specifically designed for English, and the challenge that we faced is in Swahili, it struggled on the way. Our evaluation matrices were word error rate. For the translation, we used ROG. And for summarization, we used precision and ROG recall. And for the sentiment analysis, we had accuracy. So this is, it shows the data collection and processing pipeline from the data acquisition from the Mozilla corpus, which we totally accredit them for the opportunity and contribution to the open source environment. As you can see, we have an example of an audio, a sample audio, and a spectrogram of that audio. So our platform, we've worked on a platform that can be utilized as a learning assistant in an institution, which would offer 1, lightweight Swahili chatbot that will allow you to interact with the content. 2, we are going to optimize our solution for low bandwidth. 3, community and development participation, where we are very happy to collaborate with the local players and people who have already worked on this sector. 3, we are going to introduce teacher mode, and this is part of this, participation, or maybe part of the collaboration that we've already started. And in September, we are going to deploy this with 500 students as a testing phase, and also to include our users in mind, and then proceed to a further iteration of our platform. So currently, we already have the initial development of the platform, which can allow you to interact with the front end, at the same time fetch the models for ASR and for the chat. So the solution is already ready. I'll be happy to share with you, anyone who will want to see the demo as we walk through, and be part of what we are doing, and then we can see how we can more foster collaboration. Yeah, so basically what we are doing is at Guildcode, we are trying to foster collaborative approach into problem solving, and Sasa is one of the solutions that we've built through having like an extensive research from feedback mechanism to allow the solution to be robust in terms of applying different research, review of literature, and that's what led to SEMA. And the major thing that led me to this background is to first, I was raised in a coastal part where people who speak in Swahili, and these people would be termed as illiterate because they were not able to speak in English. And this is one of the things that led me to dive deeper into research and try to understand and solve this problem. And to finalize, we already deployed a testing Swahili code master that can allow you to learn how to code in Swahili. And from September, we're going now to learn on how the platform can be used by educational students who are learning to be Swahili teachers and English and literature. Thank you.
Thank you very much, Gold. If there are questions, we have 2 questions that we can take from the audience. Any questions?
Thank you. First, it's a comment, like this is a great initiative, coming up with something that interacts with the African language and also with the in-depth of what you're doing in Africa. I know coming up with a project needs a lot of resources and also data sets you need to expand. Like, how do you collaborate on that, and how do you get such resources for ease? Thank you.
Yeah, any other question before you respond to that? Yes.
just want to say this is an incredible initiative, well done. And I want to ask if the API is currently open and if it's something that the rest of us are able to pull from. Thank you.
Thank you. I'll start with the first question. So on the resources, as a new community, we were able to utilize open source resources from trying to utilize our local compute and working 4 hours or 6 hours using a TPU, and then it refreshes, we wait for 2 days. This is one of the things that led us to use more time in the development. And then another thing also, we were working with a team across Africa, which also had a challenge, and also we were able to come up with a product management strategy where we were able to split the implementation strategy. And so for the compute, we utilize local, and Google supports TPUs and GPUs. And we also ventured into research, where we did an extensive review of literature, which led us to Wave2Vec and Whisper, which initially didn't perform as we expected it to do. And so to answer the second question, we actually pushed our model to Hugging Face, where each and every one of you who want to utilize it, it's there for use. So we're currently trying to manage the API inferencing for us to deploy this in the university setup, which we have already started, and by September intake, we are going to have 500 students utilizing our solution.
Thank you. Thank you very much. The next presenter will be from Data Science Nigeria, Abuja.
Hello, everyone. My name is Patricia Ojonoka-Idako. I'm a PhD student at the African University of Science and Technology, Abuja. I'm here to present our community project for the DSN Abuja Community Group. Our project is titled Lafiya Lau. Lafiya Lau is a Hausa phrase for good health. And we aim to use AI to tackle cancer misdiagnosis and late detection in Africa with AI. So we are all aware of the dire situation of cancer crisis in Africa, especially Nigeria. There's an alarming increase of cancer cases. So we brainstormed on how we can use AI to alleviate or to reduce the prevalence of late-stage cancer in people. So about 70% of cancer cases in Africa are diagnosed at late stages. So, and another problem is that there are a limited number of pathologists, 1 in 1 million people in many regions across Africa. And also, misdiagnosis and delayed treatment due to lack of infrastructure is a common problem among lots of health facilities across the region. Also, current methods for diagnosis are really expensive, they are slow, and they are not scalable to rural clinics. So our solution aims at early detection so that we can improve survival rates by 90%. If the cancer cases are detected early, treatment can start early, and patients will have more chances of survival. So our solution is an AI-assisted cancer detection platform. We used our data set. We had 2 categories of data. Our first data set were from biopsy images on cargo, and then we also got biopsy images from the National Hospital, and then we used convolutional neural network to train the architecture, and we used binary classification of benign and malignant to be able to detect images that show, whether it's benign, the patient doesn't have cancer, or malignant, the signs of cancer cells in the images. So we deployed it on low-cost digital microscopes and mobile devices. So the key innovation is the user interface and the use of visual explainability using GradCam. GradCam is a way of visually, is a way to visualize or explain the decision-making process of CNN. So with the GradCam, we're able to use heat maps to show the region in images that are relevant to the CNN classification. All right, so like I mentioned earlier, our data sources are open histopathological cancer images from Cargo, and then we got biopsy samples, anonymized and ethically sourced from the National Hospital, Abuja. So people from Nigeria know that National Hospital Abuja is one of the biggest tertiary health institutions where lots of cancer patients are being attended to. So our data does not have categorization in terms of the type of cancer. We just want to know whether the image is tells whether the patient has cancer cells in their body or not. So we've not gotten to this, we do not see the need to categorize maybe breast cancer, cervical cancer, and all. So it's general biopsy samples. So our model details, we use multi-layer CNN. We built it with TensorFlow, Keras, and the evaluation metrics. Okay, we can see the flow there in the image. I don't know if it's very clear, if you can see it. Our evaluation metrics use precision, the standard metrics of precision recall, an F1 score. And we can see our precision is 83.93%, recall is 75 plus 0.13%, and the F1 score is 79.30%. Now, using the confusion matrix, we can see that the dark blue box, that is the true positive, we got about 23,000 images that were evaluated as true positive. That means it shows that, yes, the images are malignant. And then, or not, either it's truly malignant and it's truly classified it or not, or whether it's benign and the model was able to really accurately classify the image as benign. Then the bottom right, the sky blue, is it sky blue? The bottom right is the true negative. And we can see that images that are benign, that is that don't have cancer cells, benign, were rightly classified as benign. But then the false positive and false negative, the number of images are low. So we can see that the model, the CNN model that we use, did reasonably well. I was able to accurately, to a great degree, predict whether the images are benign or malignant. So, like I explained, the recurrence results are 83% accuracy, and based on the confusion matrix, you can see that it's balanced. The result is quite acceptable in terms of accuracy and precision, and it shows that our model, we have much confidence in the performance of our model. So our next steps after testing the models and evaluating the model and seeing that yes, it's doing really well, our next step is to expand our data set to improve the generalization. That is to get more categories of images for patients being evaluated or diagnosed for different kinds of cancer. Like I said, we did not categorize at the initial stage of our data collection, but we realized that more of the images were for breast cancer and pelvic cancer. So, but we want to get more images for diagnosis of other cancer patients for other categories of cancer. And then we'll also continue to extend on the visual explainability and build and test lightweight models, lightweight mobile and WhatsApp-based application. So the mobile application is the interface is going to be used by healthcare workers at the last mile. That is healthcare workers, healthcare community workers in rural communities. Most rural health facilities do not have full-time oncologists or full-time doctors. So we want to be able to create an interface that makes it easy for the healthcare attendants who attend to patients at rural level and also the pathologists to be able to use AI to get intelligence on the status of their patient samples. Okay, we also intend to use WhatsApp-based application so that they'll be able to communicate with doctors and pathologists and oncologists and healthcare workers in the urban center. So the solution is going to be a bridge between the rural and the urban healthcare workers. And then also we hope to be able to integrate with hospitals to test the solution on rural levels. Thank you.
Thank you very much. Because of time, due to time constraint, we are going to take only one question. So if you have further questions, please, you can meet with the presenter and the team outside after the presentation. Thank you very much. Is there any question?
Yeah, thank you so much for the very impressive project. I'm a medical doctor from Tanzania, and I've been working on this project. And the challenge has been not only to make the model to classify the benign and malignant, but actually how to integrate it on the devices like microscopes in such a way that they can be able to analyze these images automatically. So, how did you address that challenge? But congratulations for the very impressive project. Thank you.
Okay, so the initial images we used were already processed, and then the images we got from the National Hospital. Luckily for us, the equipment used, the microscopes used, produce high-quality images. However, one of the challenges we'll face is that microscopes at the rural level, where the solution is going to be implemented, provide low-quality images. So we are still trying to find a way to integrate the images there to be able to filter them enough to be relevant or to be useful for our models. And also another solution is being able to improve on the standard of microscopes in some of the health facilities, but that is a long shot. But we are looking at tools to be able to process the images from the microscopes so that they will be useful and they'll be able to provide accurate results through our models. Did I answer you?
Thank you very much.
All right.
Can we appreciate the presenter? The next presenter is from Deep Learning Indaba Cameroon.
Good afternoon, everyone. Today, I will try to present our work briefly. I am Melvin Foucam from Deep Learning Indaba Cameroon, and I will present our solution. According to the WHO organization, each year around Africa, we have more than 6 million cases of death related to infectious and respiratory diseases. And we can observe that climate factor increase has 20% the number of cases of these diseases. And also, if you think just about air pollution, we can observe that each year, air pollution costs about 450 billion USD. And we observe also that 80% of rural African hospitals lack of resources to manage these crises. And all these factors increase the cost loss each year in Africa around 800 billion USD. The question now is, how can we protect African community from this growing crisis? Ladies and gentlemen, we present REACT, an AI-driving outbreak forecasting and alert system where we combine IoT and AI to be able to forecast climate-driving respiratory outbreak early. Our vision is to predict, alert, and protect our community. About our general overview of our solution, we have 5 main parts. The first part is about data collection. After, we have the stream processing part. We have the predicting analysis part. We have the alert generation part, and also the recommendation part. And we base our solution under the federated architecture. Our baseline model was JRU, LSM. Why LSM? Because it enables us to capture temporal trend like seasonality, lagged effect. And JRU is optimized for low power devices in the rural case. And we try also to build a recommendation strategy using reinforcement algorithm. About our data collection pipeline, we have 4 main steps. The first one is to identify all the requirement sources. And for that, we observe we can use some data from Africa Climate AI. We have also some API online, Euro 5. And also we collect data in a few regions in my country, like South and West region. After that, we need to define a streaming injection where we use Kafka to be able to have all this data. And we define also another part where we labeling all the data. After that, we need to save all this data in 2 different kind of database like MongoDB and Redis. And after collecting all this data, we have some key insights we observe. First, air pollution and temperature drive respiratory cases, as we know, and we already see it in the previous report. Then we start to build and implement our solution. First, we build the data collection management part for all the diseases we use in real environment. Here we can observe all the devices we use in some area in my country. That is one specific part called West Region, in locality called Chang. We put some devices in some place. We are able to have all the name and all the label of each device. We are able to have all the resources and all the performance of all these devices. With that, we are able at every time to maintain all these devices. After that, we build first an data analysis framework where we are able to show some insight to public health sector, and also we have the recommendation part for final user. First, we need to analyze, give some insights to public health worker, and after that, we need now to generate the alert for user. And for that part, we use different kind of techniques. We use SMS, we use social network, and also we use mobile application. Now, what is the impact of our solution? First, we want to target 3 main sub-development goals, the 3, the 9, and the 11, to be able to contain disease transmission, to be able also to reduce the mortality, and to define an affordable and scalable development pipeline. And also, we care about equity. As we know, it's most rural part. You need to be sure that we can give some requirement information. And for that, we use multi-channel dissemination like USD and SMS. And we define some specific metrics for our solution. First, we need to have some precision accuracy like R square and RMSE. And also just targeting 1% of reduction of the number of cases of death and 1% of reduction of economy burden, we will be able to save approximately 60,000 lives annually and also save 12.5 billion USD annually. And during our implementation plan, we faced different challenges. The first one was the connectivity issue, and we have poor line connecting condition in some area, and you can observe the main challenge like data quality limitation, because we need to be able to collect data around different spaces.
Time up.
Thank you.
Thank you very much. Questions?
Thank you for your presentation. I want to ask some questions. You said you have used federated learning. What tool?
I say federated architecture.
Okay.
Yeah.
What challenges have you faced? You have talked about internet connection.
Yeah.
By example, how do you manage it? If one device don't send the data to the edge, and how do you manage it? And how many months have you taken to develop the project?
Okay. For the first question, we think that to solve this query, we need to use edge AI. Like you will build a solution on all the device, then you will be able to definitely generate after the prediction on the device, the alert automatically. We will not need to go forward to the first save the data. We'll directly try to predict with this data, share some analysis if you don't have this kind of connection. And for the second question, we started the project since, I will say, 6 months. We are working still on it, and we want to deploy it in real environment in most of our cities in our country.
Thank you very much. Can we appreciate the presenter? The next presenter is from Data Science Nigeria, from Federal University of Technology, Akure.
Hi. Have you ever walked through a pile of refuse or an empty bottle and you did not feel any urge to act? No, I'm not judging anyone. I've also done the same. I live in the part of Nigeria that is known to be the economic hub of West Africa, Lagos. Lagos is home to over 60 million people, and in every hour, 77 new people enter Lagos. As a result, Lagos generates over 16 million tons of waste annually. Now, let me make you see the picture of 60 million tons of waste. Imagine you filling up 100 standard football stadiums annually with waste, and less than 10% of this is being totally and properly cleared. This, as a result, you see tweets like this: Lagos is a very dirty state, Lagos is smelling and all that, almost every day on social media, but no one is ready to act. Next slide. We now begin to ask, why does this problem persist? We ask people and they'll be like, it's not my responsibility, it's the duty of the government. We realize that we as Africans, we are beginning to lose our Ubuntu spirit, the spirit of collective responsibility to one another and also to our environment. People also say, there's nothing in for me, even if I pick up the refuse, no one is going to see me, so why should I do it? I'm not going to get anything in return. This is why CleanSight is here. At CleanSight, we aim to empower Africans and to restore our Ubuntu spirit to our community. With CleanSight, you auto-verify cleanups, geotag waste hotspots, and reward users with redeemable points. Now, before I go into the how it works, I want to walk us through the technical implementation. While we were working on CleanSight, we realized that while we were trying to solve the problem of environmental waste pollution, we are not just solving that problem alone, we are solving another problem. Since Sunday, I've been interacting with AI scientists and researchers all across Africa, and they keep mentioning the same thing, the same problem they're experiencing: lack of adequate data. We experienced this as well while building CleanSight, because we realized that most waste data sets that are available are not peculiar to African wastes. They can recognize water sachet nylon, bottles, and some other things that is peculiar to African wastes. As such, my team and I developed a low custom data set which is peculiar to African wastes. But with CleanSight and with full deployment of CleanSight, we hope to develop the largest African waste data set by 2027, together with you, together with me. Now, We got our primary data sets, just as I mentioned earlier, from RoboFlow, and we also added our custom data sets, which is peculiar to our waste here in Africa. Now, how does this system work? How does CleanSight work? For example, as a user, once you see a pile of waste or an empty bottle lying around anywhere, you take a picture of it, which we call the before picture. Then after cleaning, you take another picture, and which we call the after picture. Then you upload it on our portal, and CleanSight then verifies to make sure and to ensure that this same area you mentioned you cleaned up is the same area you are uploading on the portal. After the verification is completed, we then award you the points, which is calculated using our cleanliness score. Now, the technical implementation. We developed CleanSight using YOLO version 11 medium, which we trained with our data from RoboFlow and our custom data. After this, we also tried to ensure that we verify the location, because we are also trying to geotag areas in Africa that we know that, okay, this place is like hotspots for waste. This will help government agencies and also researchers to know which area to focus on when they are doing their research. Now, I mentioned something that we award our users with points. We award them points after cleaning. How do we calculate these points? We calculate these points using our cleanliness score. That is, the trash count before cleaning minus the trash count after cleaning divided by the trash count after cleaning. That way, we'll award them a point based on the efforts they've put into trying to clean up the environment. Now, how do we verify to make sure that, okay, this is the same area that you are cleaning and not another area, not another random picture? We use the terminology called the cosine similarity score, where we calculate, we verify to make sure, okay, this is the same area by looking for patterns in the images to ensure that, okay, this is the exact area that you mentioned that there's waste and is the same exact area that you are cleaning. Now, you might be wondering, some might want to trick our system into just, okay, there's no waste here now, I want to trick the system, just drop something and upload on the portal. During our implementation phase, we've been able to geotag certain areas that we know that these areas are hotspots to waste. For example, in Lagos, there are some areas that already know that these areas are like high waste areas. As such, you cleaning up environments like this with your community members, you get more points. If you clean up the community individually, let's say, for example, you get 10 points. But when you come together as a community, you get more points for coming together as a community. That is, we are leveraging the African spirits. We are leveraging the Ubuntu spirits, building and changing Africa by Africans. Now, this is a demo of our portal, which the link, the QR code is on the last slide. So once you get to our portal, after registering, you get to the landing page, then you click Start Cleaning, which takes you to the next page where you can upload the before picture. Then after cleaning, you upload the after picture. Then we'll verify and our system take up the rest. Now, with every problem, there's a challenge. When you're trying to solve a problem, there's usually a challenge. What are the challenges that we anticipate before our final launch, before the end of this year? One of the challenges is funding for scaling, because this problem is not only peculiar to Lagos, where I come from, it's peculiar to other major cities across Africa. And why are we focusing on cities? If you want to visit a country, you go to the city first. So we want to make sure that when people come into our cities, they see this area is clean, they see this spirit of oneness and wanting to make sure that our environment and everywhere is better. Now, we also aim to partner with organizations. We are currently working on partnering with Alternative Bank, which is a bank in Nigeria that has an initiative, a West Wales initiative. So by partnering with them, we hope to give our users prizes for taking action towards the community.
Time up. Time up.
Thank you very much.
Yes, questions?
Thank you very much for your wonderful presentation. My name is Kudus. I'm also from Lagos. You mentioned something around monitoring of the waste evaluation and verification. My major concern here is what are you doing in terms of educating people on proper waste management? I mean, somebody can pick up waste from the streets and then, I don't know, where are you expecting the guy to go and drop it? Because at the end of the day, if the guy gives the waste to the individual that comes to carry waste or pick up waste, they ended up dropping it on the streets of Lagos. So what are you doing in terms of that? Thank you.
Yes, you can respond.
Thank you very much for the wonderful question. I mentioned earlier that we are leveraging our spirits, Ubuntu spirits, as Africans. So, as Africans, we are communal people, and we are leveraging this using CleanSight. We are currently working on partnership to train community members on proper waste disposal. From there, let's say, for example, after cleaning, what's the next thing? That's why I mentioned something about partnership for waste to wealth initiative. By partnering with organizations, the alternative bank I mentioned, people now take deliberate effort because they know that once they do this, once they dispose their waste properly, there is a reward for them. Price, actual, alternative bank reward certain kg, 15,000 naira per certain number of kg. So that way, when people know that there's something in for me, they take more deliberate actions towards proper waste disposal. Thank you.
Thank you very much. I will hand over to my chairperson.
Amazing. Let's acknowledge the presenters once again. Please give them a round of applause. Yes, in absentia, we have the AI-powered drones for smart crop management in Africa by the Tech.ai. They were not able to make it, but we will share the presentations afterwards so that you can be in tune with what they were working on.